According to this problem, a truck is stopped at a stoplight and when the light turns green, it accelerates at 2 meters per square second. So if you represent its acceleration by a index t, it's equal to the 2 meters per square second. At the same instant, a car moving with a speed of 36 kilometers per hour passes the truck. So the velocity of car is equal to the 36 kilometers per hour. Now we are supposed to find when and where the truck catch up with the car. Here you can see that the motion of the truck is uniformly accelerated motion, but the motion of the car is a uniform motion, and both of them are moving on a straight line, where you can define an x-axis with origin at stoplight. This is the x-axis, and this is its origin. At the origin of this axis, the position of the car and truck, that is x index 0, is equal to the 0. And you can assume that time at this point is 0. Now, as you know, for one-dimensional uniform motion, position in terms of time can be found from this relation: velocity times t minus t0 plus x0. And for this case, position of car is equal to the velocity of car times t, because t0 and x0 are equal to the 0. But here we index c is equal to the 36 kilometers per hour. That is equal to the 36,000 meters per 3,600 seconds. That is 10 meters per second. So the position of car in terms of time is equal to the 10 times t. This is the first relation we found for this problem. When an object is in uniformly accelerated motion on one dimension, its position can be found from this relation in terms of time. X of t is equal to the 1/2 a times t minus t0 squared plus v0 times t minus t0 plus x0. So the position of truck at any given time is equal to the 1/2 times a, that is 1/2 times 2, that is 1, times t minus t0 squared, and t0 here is 0, so this is t squared plus v0 times t minus t0. v0 here is 0 because the velocity of truck was 0 at stoplight. And x0 is also 0. So this is the second relation of this problem that gives us the position of truck at any given time. Now, according to these two relations, relation 1 and 2, you can see that when x index c equals x index t, you can find the time when truck and car are at the same point on the x-axis. And you can find two values for t, which are 0 and 10 seconds. T equals 0 belongs to the origin of the x-axis, and t equals 10 is when the car and truck meet each other again. Now, if you substitute t equals 10 in one of these two relations, you can find the position of the truck and the car when they meet each other. So, if you substitute t equals 10 in relation 1, you can get the position of the truck and car when they meet each other again. That is 100 meters.